Okay, so let's move on to part two of our lecture and look at the hydrologic cycle. Now, there's a video and animation in the study module, or I mean in the weekly course module on the Canvas page, so make sure you watch this because it'll give you a little bit more detail. Um, all we're looking at with the hydrologic cycle is just how water moves from place to place, how water, ice, and water vapor move from place to place. It basically flows through the atmosphere, then across land where it's either stored as ice or groundwater, and then it goes back to the ocean, and solar energy empowers the whole cycle. And basically, here's what it is. So we're up in the atmosphere, we get precipitation, falls down into the water, into the oceans. Okay, then that evaporates, goes back up. The atmospheric water vapor is moving because of advection that we kind of talked about last week, horizontal movement of heat energy. Clouds will form over land, and then the moisture comes down as precipitation. Now notice, because again, most of the earth is covered with water, so 78% of the precipitation falls back into the oceans. 22% falls over land, and you add those together, it's 100% precipitation. Now, out of this 22%, some of it evaporates or transpires right back. Transpiration is like when plants breathe. They intake air and transpire water and oxygen. So the water goes back into the atmosphere either through evaporation or transpiration. Some of it runs off to the surface. The remaining 8% runs off, goes right back into the ocean, or comes back down as groundwater. And so that makes 100% of the whole cycle just keeps going on and on. That's the hydrologic cycle. Evaporation, precipitation, runoff back to the ocean, and just going on and on and on. So listen to the animation in the course module, the course module. We'll go over in a little bit more detail. So you can have a budget, just like you have hopefully you have a financial budget like your checking account. So you have an input, precipitation, you have an output, which is evaporation and transpiration. Then you can do this for local scales, for regional scales, or even for the continent. And that helps us to evaluate the water availability for a given area. So that's what you do. You just take into account the pluses, precipitation, that's your input. Then you subtract the minuses, the amount that goes out for evaporation, flow to streams and runoff, and transpiration for plants. What you have and goes into the soil moisture zone as groundwater. So out of that, you will end up with either a surplus or a deficit, and that allows you to plan for the future in terms of drinking water, water for agriculture, and things like that. Okay, so one thing that you need to be, let me go back on this, concerned about is this: the evaporation from land and water. And precipitation, now that's the water supply to the surface, and it exits the surface through evaporation or through transpiration of plants. The intake air into the leaves of the plant, and when they exhale, they give back water vapor and O2, and that is known as evapotranspiration. Now, there's two types. There's what we call actual, A-C-T-E-T. That's the amount of water that returns through the atmosphere through evapotranspiration. And what we call potential evapotranspiration is the amount of water that would evaporate if the water supply is always present. So this is like theoretical amount. This is the actual amount. So this is going to vary, but this is kind of the baseline when we create these models. Now, you get places like here, and I think this is Algeria, where you have oases in the middle of the deserts. Dug a well, drilled down, and dug a well, so water will come up to the surface. Even in these desert areas, there's still water underneath the surface, and they'll use it, to grow some, some agriculture, to grow date palms and so forth. But ethnic groups practice transhumanism movement, the seasonal movement animals will use these oases as stopping points to nourish their livestock. So here's what it looks like. Here's your moisture supply equals the actual moisture demand, which is these two, plus your moisture oversupply, and then that's your savings or your deficit. So you'll have one or the other. The book goes into this in a little more detail, so pay attention to that in the book. Okay. Now, you have soil moisture. That's your precipitation and runoff, which adds moisture to the soil. That's very important. That's how we recharge soil moisture, is by rain coming down, percolating through the very top layer of the soil into the ground. Deeper down it goes, it gets below the root area of the plants, and so the plants are negatively affected. Either they don't get enough to begin with, or the water goes too deep and they use it all up. This is just one way of looking at it. This is darker, the more soil moisture per cubic meter there is. And into this in a little more detail in the upcoming chapters, but this is the Atlantic Ocean. This is the east coast of the United States. This is the Gulf of Mexico. So this warm water from the Gulf Stream, or Gulf of Mexico, enters the Atlantic and goes up the east coast. Because it carries a lot of heat energy, there's a lot of evaporation, so therefore a lot of precipitation, and it falls down on the ground, and that runs back down to the coast. And so the coastal areas along the east coast have high content of soil moisture, the highest in the US. Now, you can have a water deficit, which we in California know is a drought, when there's less precipitation and also higher temperatures. They will produce drier conditions over an extended period of time. There's different levels of drought. The meteorological one, which is a regional average, the agriculture, where it affects crop yields, what we call the hydrological drought, which is the effects of rain and snow shortages on water supply. If you've been following the news, we're way, way, way above it this year. In terms, I think we're 141% of normal, which is great for the state of California because it will mitigate all these. Use water causes, remember in droughts, we have to monitor our intake and use of water at home. And as we've seen recently, if there's less water, you're going to have increased forest fire severity, especially it was all over California recently. And a lot of that has to do with these prolonged droughts. Okay, so let's take a break, and when we come back, we'll look at how we apply these water budget concepts.